Introduction. When we pull bucket full of water, we find it difficult to pull. But if we use pulley to lift the bucket, it becomes easy to lift the bucket from the well. Same way, when we lift heavy load to the building, such as cylinders on ramp, inclined plane, it becomes easy. These are some examples of simple machines. Machine. Machine is a device which overcomes large hindrance resistance by applying force in a convenient direction. Like in case of pulley, the effort is the longer direction of the force of gravity. It helps us to do the work easy. Nowadays, we cannot think of our existence without machines. Simple machines. A machine is a device which makes our work easier and simpler. It helps us to increase the efficiency to work. Examples: if we have to open the lid of the sugar tin, we may do it with the bare hands. If we take a small spoon and put it in between the lid and the edge of the tin, it will open easily. Similarly, a man has to lift a box. He needs great force to put it inside the truck, but he can push the same box up with an inclined plane very easily. The amount of work done in both the cases are same, but the inclined plane allows the man to apply less force. Hence, the inclined plane works as a simple machine. Machine helps in carrying out unsafe and dangerous tasks also. Example: pair of tongs can be used to lift the piece of burning coal from the fire. General term of a simple machine. These terms are used frequently in studying simple machines. Effort. It is the force applied to the machine to do mechanical work. Load. Load is the force that a machine exerts on a given body to be moved. Fulcrum. It is a fixed point about which the machine can turn while doing work. Mechanical advantage. It is measured as the ratio of the load to the effort. Mechanical advantage is equals to load upon effort. Here, mechanical advantage tells us the advantage gained by using the machine to transmit force. Input. It is the work done on the machine, that is, the energy supplied to the machine. Output. It is the useful work done by the machine, that is, the energy imparted by the machine. Efficiency of a machine. No machine is an ideal machine. Some parts of the input is lost to overcome the friction of moving the parts of the machine. The ratio of the work done by the machine, work output, to the work done on the machine, work input, is called the efficiency of the machine. Efficiency is equal to work output upon work input. Now let's see some mechanical advantages. Machines are used for the following purposes: to overcome a heavy load by applying a small effort. Example, a jack is used to lift the car. To transfer the effort at convenient point. In a bicycle, effort is applied on the pedal that is transferred to the wheel. To apply the force in a desired direction. Example, In a single fixed pulley, effort is applied in the downward direction. To gain in speed, example, instead of walking, if we use bicycle, it will take less time to reach a place. Now let's see different types of simple machines. First, lever. Second, wheel and axle. Third, pulley. Fourth, inclined plane. Fifth, screw. Sixth, wedge. Do you know, simple machines are the devices that make it easier to do work against a force. Lever. It is a simple machine and is long bar which moves around a fixed point. The fixed point is called fulcrum. The object which is to be moved or lifted is called load or resistance. The force applied is effort. And the distance of the fulcrum from the point at which load acts is load arm. The distance of the fulcrum from the point at which the effort acts is called effort arm. A lever is a straight or bent part capable of rotating in any direction about a fixed point or axis. Wheel and axle. It necessarily consists of a rod, axle, and a wheel joined together such that if one is made to rotate, the other also rotates. The wheel has a larger diameter while the axle has smaller diameter. The effort is applied on the broader wheel and the load is with the axle. Such an arrangement needs less effort to move an object. Example. First, wheel and axle. Second, wheel of a car. Third, screwdriver. And fourth, drill, etc. A wheel with a cylindrical rod passing through its center is called wheel and axle. Now let's see pulley. A pulley is a simple machine which lifts heavy load with less application of effort. It is a flat circular disc having grooved on its edge and capable of rotating around its center axis called axle. A pulley is used to lift heavy objects. The pulley is hooked onto a support and is at certain height above the object and the rope is passed over the pulley along the groove. The groove prevents the rope from slipping off the disc. The load is placed over one end of the rope, whereas the effort is applied on the other end. A pulley is a wooden or metallic disc grooved rim capable of rotating about an axis passing through its center. Simple single fixed pulley. The simplest form of pulley is called single fixed pulley. In this pulley, axle is fixed to a rigid support called a block. A rope passes through the groove in the rim of the pulley. One end of the rope is attached to the rope and the other is to the effort. This type of pulley is used to draw the water from well. The main advantage of pulley is that it allows us to apply force in convenient downward direction. When we apply force downward, we make use of our own weight in order to apply effort. Thus, it becomes easier to pull the rope if the axis of rotation of pulley does not move. This is known as single fixed pulley. The another type is single movable pulley. Single movable pulley is the pulley which has a free axle to move in space. A string passes through the groove rim of the pulley One end of the string is tied to the hook and the effort is applied to the other end of the string. The load is attached to pulley. A single movable pulley has a mechanical advantage of 2. It is because each part of the ropes support half of the load. If the axis of the rotation of the pulley is not fixed, then it is known as single movable pulley. Inclined plane. An inclined plane is a sloping surface used to lift a heavy object with a small effort. You must have observed loading objects on a truck by a ramp using a wooden plank inclined at certain angle. The wooden plank actually acts as an inclined plane. An inclined plane is used as a force multiplier. This means that it can be used to lift heavy load with less effort. Examples: a road going uphill, ramp hospital, ramp mall, etc. An inclined plane makes the loading of heavy objects quite easy. Mechanical advantage of an inclined plane: for the work input, we look at the slope of the ramp, and for the work output, we look at the height of the ramp. Wi is equals to Wo. Fes is equals to Fih. Fi upon Fe is equals to S upon H, where S is equals to slope and H is equals to height. Mechanical advantage is equals to Fi upon Fe is equals to S by H. Now let's see screw. A screw is another application of inclined plane. It is an inclined plane found around the rod. A screw looks like a nail with grooves cut around. The tip of the screw is narrow and pointed, and as we move away from the tip, the thickness of the screw increases till we reach the head of the screw, which is flat. The head has a narrow slit in it which is used to turn the screw. The grooves of the screw are like inclined planes. As the screw is rotated into a piece of wood, it travels at a distance that a nail can travel. Thus, a screw, like an inclined plane, is the force multiplier. Wedge. A wedge is also an example of inclined plane. It is a portable inclined plane. A wedge is a simple machine, that is, it is two or more inclined surfaces joined together to form a sharp or pointed object. The wedge of a knife and a razor blade is made up of two inclined planes put together. Wedges work on the principle of using the surface area so that a minimum force is required to produce the maximum pressure. Wedges are generally used to split or pierce materials. Knife, axe, an iron nail, pin, sewing needle are some of the examples of wedge. Now, different orders of lever we are going to study. There are three different types of levers depending upon the relative positions of fulcrum, load, and effort. Now, let's see the first class lever. Class 1 lever. In class 1 lever, the fulcrum is in between load L and effort E. Examples are a beam balance, a seesaw, a pair of scissors, and pliers. As you can see in the figure. Now let's see class 2 lever. In a class 2 lever, the load L is in between fulcrum F and effort E. Examples: a nutcracker, a bottle opener, and a wheelbarrow. Now, class 3 lever. In class 3 lever, the effort E is in between fulcrum F and the load L. Some of the examples are kitchen tongs, forceps, sugar tongs, human forearm fishing rod. I hope you have understood all these three levers with suitable examples and figures. In third class levers, we do not gain in terms of effort, but these levers are used to do the work faster or to do the work in a convenient direction. Now let's see an activity. Suppose you have to shift a heavy stone from its position. If you simply do it by pushing, that is by applying force, you will observe that stone cannot be shifted easily. Now, you can take a long wooden bar and put a small brick in between the stone and yourself and apply a force as indicated in the figure. You will observe that stone can be easily shifted from this activity. We can conclude that the long wooden bar starts acting like a machine which makes the work easier, and with the less effort the stone can be shifted. I hope it's clear to you in the figure. See how the stone is shifted. It's moving with the help of a long wooden bar and a small brick. The last topic is maintenance of machine. We use a variety of machines which makes our work easier. If a machine is used for a long time, there is wear and tear in it due to friction. For this reason, it requires maintenance. Following steps should be taken for taking care of these machines. First one is, if you have to avoid wear and tear of unwanted sound in machines, proper lubricants should be used. It can be like grease, oil, etc. These can be used periodically. To avoid rusting, the parts of machines should be painted. To protect it from dust and moisture, the machine should be properly covered when it is not in use. A machine should be regularly cleaned and checked up for any deficiency. If you take care of these following steps, your machine will work properly.